Here you see an example from the previous lecture. Let us work out this example. And this is a typical example of the questions that you will have in your midterm and final. This particular example is simple enough that we can solve it in a quarter of a lecture hour. But it is also difficult enough since it has different joints and links in it. Let us start with this red frame. We are giving you a frame. We are calling it x5, z5. This is a frame attached to the end effector. That is, our task and goal is to find the transformation from the base to that frame. So, we now have frames from 0 to 5. And we need to find the DH parameters for these frames. And this is x5, z5 frame. And this frame is given to you here. It might not be given, and we could ask you to assign it yourself, but in this example it is given. What you see here is that you have an axis. This is the joint axis. This representation describes our revolute joint, the output of which defines axis 1. So this is coming out of the output of joint 1. The second joint here is a prismatic joint. So it is represented this way, and the output is coming to define the link that leads to the next joint, which is axis 2. The third joint is a revolute joint, and its output is defining the third axis. The third axis is coming out of the plane, and you see that it is represented by a circle and a dot in the center. Can you visualize how this robot is moving? Imagine that it rotates about the first axis counterclockwise. Then you can see that the end effector is going to come out of the plane. Now, what we need to do is the frame assignment. And we are going to start by assigning origins and z-axis. So you see the first joint axis. The second one, what particularity about those axes do we have? Intersecting. Joint 1 and 2 are intersecting. So the intersection point is going to be an important point. In this case, it is going to determine an origin. How about axis 2 and axis 3? Are they intersecting? The answer is no. They are parallel. Basically, they are in two parallel planes. When we come to the next one, the fourth axis, it is intersecting with the axis number 3. So we call this mechanism an RPRR robot. That is revolute, prismatic, revolute robot. Let's continue. And I am going to continue by putting the z-axis and the origins. So z1 is a long axis about which the first rotation takes place at joint 1. z2 along the sliding direction. z3 is coming out of the plane. z4 is the axis about which the rotation at the fourth joint takes place. And there is basically no question that all of these are directly assigned very simply as dictated by the motions at the joints. And we are introducing a little bit of distance here, and this will be clearly defined when we put the origins. Let us continue by placing origins now. Firstly, origin 1 is there, but could you answer why we are selecting origin 1 at that point? This point becomes the origin of frame 1 because we have the intersection of Z2 and Z1 at this point. So origin 1, that is O1, is imposed. But we put O0, the origin of frame 0, at that location because we want to minimize the number of parameters. If we put O0 lower or higher, we will have a distance that we need to account for by an additional parameter. So, coming to the next origin O2. O2 happens to be here. And how did we assign it at this location? It is because the common normal between Z2 and Z3 intersecting with axis Z2 at this point. That is how we get O2. What about O3? O3 is here at the intersection of Z3 with Z4. Now, O4. So how do we define O4? It is along the common normal between axes Z4 and Z5. Z5 was given here, as seen here, parallel to Z4. How many common normals do you have between Z4 and Z5? Infinite. So we have a choice. We can put O4 in different positions. We are going to select O4 there, and that will contribute to, as we will see, to minimizing the number of parameters. Now, let us start to introduce DH parameters. Firstly, what is A0? A0 is the distance between which axes? Between Z0 and Z1. But they are coincident. So, A0 is 0. What about A1? Again, it is the distance between the z-axis 1 and 2. So, it is also 0. What about the distance between Z2 and Z3? That will give us A2. So, there is some distance. In fact, there are distances that are not appearing on the figure. And we are going to introduce them. Therefore, now we are going to need a parameter that describes the distance from O2 to O3. And that distance we just put an L2 there. We are going to need that distance, which we show by L4. It is actually depending on the location of O5. And we are going to need this distance to O5 to show the distance between the origins along the x-axis. Now we need to assign x-axis. So far we have been introducing parameters without assigning the axis. What is the first one? x1. It is perpendicular to the plane containing z1 and z2. It could be in or out. We are selecting x1 out. It could be in, but then we would need to change angle sign. x2. How do we define x2? It is along the common normal between Z2 and Z3. And it points from O2 to O3, that is X2. X3, where is X3? X3 is the common normal between Z3 and Z4. In other words, it is perpendicular to the plane formed by Z3 and Z4, and we selected up. X4 is along the common normal between Z4 and Z5. Its direction is from O4 to O5, so the arrow will be downwards. So, now I am going to show you the table and we are going to see the parameters.